Yesterday we were discussing permutations, which is a way of arranging items where each order is different. Today we're discussing combinations, which eliminates different orders. So we talked about permutations, and we looked at an example with floats in a parade. And the different ways that you arrange the floats make for different parade setups, right? But we also talked about CDs. We talked about you're a band, you've got 12 songs, you want to put 9 of them on a CD. And we said we use permutations because we said putting one song first is different than putting that same song third or fourth or fifth, and all the orders are different, right? What if we didn't care about what order they went on the CD? We just wanted to choose 9 songs. That would eliminate a lot of the options, and that's when we use combinations instead of permutations. So, for example, example 1 says, count the combinations of 2 letters from the list A, B, C, D. Well, let's think about the ways we could put them together.
A, B.
You got A, B, A, C, A, D. You got B, A, B, C, B, D. You got C, A, C, B, C, D, and D, A, D, B, D, C. 12 different ways, right? So if we just pick 2 letters at a time, we get 12 different options. But, suppose, I don't know, these are prizes that are identical, right? Or these are people that you're grabbing for 2-person teams. Does it matter who's left and who's right, or who's, on which side of the coin? It doesn't. AB and BA are identical, okay? We only need one of them, okay? AC and CA are identical. We only need one of them. We don't need both AD and DA. We don't need both BC and CB. We don't need both BD and DB, and we don't need both CD and DC. So how many do we actually need? 6, not 12. So this brings us to a new formula for combinations. Remember that yesterday for permutations we said that NPR was equal to n factorial over n minus r factorial. So for NCR, we introduce a little something more to help eliminate all of those extras. So we have n factorial over n minus r factorial, r factorial. So that extra r factorial on the bottom divides out all of those extra arrangements. So if you look at example 2, it says you order a sandwich at a restaurant. You can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? Now, does it matter what order those side dishes come in? Does it matter which is on the left side of your plate and which side is on the right? Not unless you're like severely obsessive compulsive. It doesn't matter. So we can use combinations instead of permutations. Okay? We have 8 possible side dishes, and we're going to choose 2 of them. So instead of doing 8 pick 2, 8 permutations, we do 8 choose 2 because we don't care what the order is. And so our calculation, our formula is 8 factorial over 8 minus 2 factorial, 2 factorial. Now, 8 factorial, you really don't need your calculator because we have 8 factorial and then we have 6 factorial. And we have 2 factorial. Now notice that 6 factorial cancels out most of the 8 factorial, leaving us with just 8 times 7 on top. But we also have the 2 on the bottom, which will reduce with the 8, making it a 4. 4 times 7 is 28. This 6 factorial that came from the 8 minus 2 factorial, that 6, 5, 4, 3, 2, 1 cancels out this 6, 5, 4, 3, 2, 1. 7 times 4 is 28. I reduced that 8 with that 2.
Oh,
Bring that down to 4.
Oh, so you don't have to do.
No, because you reduce it, you get 28 anyways. You can kind of reduce ahead of time. And let's look at another one. A yearbook editor has selected 14 photos, including one of you and one of your friend, to use in a college for the yearbook. There's room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? Does it matter who's on the left and who's on the right? No, so it doesn't matter what order you're picked in. We're just picking, we just want to know how many, what the probability is that out of that 14, they choose the 2 photos of you and your friend. This will tell us the number of ways we could choose, or the probability that we'll choose you and your friend. Okay, so this is going to tell us 14 choose 2 is how many different ways we could pick 2 photos to be at the top, right? So we have 14 factorial over 14 minus 2 factorial, 2 factorial. So we have 14 factorial, which is 14 times 13 times 12. I'm just going to write it times 12 factorial. Okay, instead of writing out 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Because 14 minus 2 is 12, so that gives me a 12 factorial there. And then I have a 2 factorial, which is 2 times 1. So the 12 factorial that came from here and the 12 factorial that came from the end of the 14 are going to cancel each other out. And the 2 is going to reduce with the 14, making it 7. And 7 times 13 is 91. So there's 91 different ways they could pick 2 pictures to go at the top, right? How many different ways could that be you and your friend? Not even. Nope. There's only one way that they could pick you and your friend, and that's that they pick you and your friend.
Oh.
The only way there could be more than one way is if there was more than one picture of each of you guys.
So that's 1 out of 90.
So the probability that they pick your 2 is 1 out of 91. The only way that probability increases is if more of those 14 pictures are of you or your friend. Okay? So there's 91 ways to pick 2 pictures, and since there's only 1 picture of each of you, there's 1 out of 91 ways to pick you 2. Make sense?
Yeah.
Okay.